So let's do an example. Let's evaluate the triple integral over b of the function x squared yz dv if b is a solid box where x can be any number between 2 and 3, y can be any number between 1 and 6, and z can be any number between 4 and 12. Alright, so one possible answer to this is to set up an integral that ends at the end. Let's write these integrals with a little bit of space between them, of the function x squared yz, where the dv here gets replaced with the dx, dy, dz. That is one order that works. But since dx is all the way on the inside, then the inner integral should go from 2 to 3. The middle integral is the dy, so it should go from 1 to 6. And then on the outside is dz, so the outer integral, 4 to 12. Okay, and then if we just go through some steps for this, this should be integral 4 to 12, integral 1 to 6. Just focus on the inner integral, and we should integrate with respect to x. So 1/3 x cubed yz, evaluating at 2 and at 3. Copy still the dy and dz. Then we'll have integral 4 to 12, integral 1 to 6, 1/3 times 3 cubed yz minus 1/3 times 2 cubed yz dy dz. Certainly at this point there's more work to do, but let's stop there. I think that's a decent pausing place. I think you'll be fine finishing that off. A second way to set this up, going back to here, we could say that this is equal to integral of x squared yz, and we can switch up the order. Have dz, dx, dy. But if dz is the innermost, then we should have 4 to 12 here. And dx is the middle, so then the middle integral sign should have 2 to 3. Those are the x values. Dy is on the outside, so the outer integral, 1 to 6. I hope that seems to make sense, right? So we won't actually even get started for this one. Just comment that after doing inner integral with respect to z. So treat z like a variable and treat x and y like constants. Then you'll get what you get will look more like the double integrals from before. Yeah, because you'll only be left with a dx dy when that happens. Okay, I would suggest that you should on your own try all the possible combinations. So there's dx, dy, dz, which was written up there. We just saw dz, dx, dy. This isn't all in a great order. Maybe we'll stick this over here. The one that starts with z, dz, dx, dy. But there's another one that starts with dx, right? So you could have dx, dz, dy. So try them all, right? How many of these are there? There's actually 3 factorial. So try all 6. Got to collect them all. So let's see, the ones that start with dy, so there'd be dx, dz, and then starting with dy, there's dz, dx, and the only other one starting with dz would be a dy, dx. So try setting them all up, and then try evaluating all the way through on at least several of these.